Okay, picture this. You've just built your very first Claude integration, right? You fire it up, you type in a prompt, and then nothing. You just watch your users sit there staring at a blank screen for 5, maybe 10 agonizing seconds waiting for the answer to show up. Look, in software time, that dead wait, it feels like an absolute eternity. But here is the secret. It's not a hardware limitation. It's not some unavoidable network bottleneck. It is a completely preventable issue, and fixing it literally takes just one line of code.
So let's dive right into this explainer and look at exactly how we can eliminate that dead weight for good. The feature we're talking about today is called streaming. Now, it's considered an intermediate-level Claude feature, but honestly, as you'll see in a minute, implementing it is a total game changer. It fundamentally transforms the user experience from this sluggish, frustrating wait into a highly responsive, dynamic interaction.
I mean, just look at the difference in perceived latency here. It's absolutely staggering. In a standard setup, your user is just staring at a flat line for 5 seconds until boom, this massive block of text suddenly drops in all at once. But with streaming enabled, those very first visible tokens are delivered in under a second. We're talking often as fast as 0.3 seconds. The actual total generation time stays exactly the same, but psychologically, the user gets to start reading while Claude is still writing. You completely eliminate the wait.
So what's actually happening under the hood to make this work? Well, streaming is built on a technical mechanism called server-sent events, or SSE for short. Basically, when you add the argument stream true to your API request, you're telling the server, hey, don't hold the response hostage until it's finished. Instead, it opens up a persistent HTTP connection and starts sending down a continuous sequence of these tiny event chunks. Each chunk carries just a few tokens of text, and your application can process and display them the exact millisecond they arrive. It's like a steady drip rather than a massive wave.
And beyond just the speed aspect, that persistent connection actually offers a crucial secondary benefit that a lot of developers miss. Think about incredibly long generations, things that might take up to 2 full minutes to process. That continuous flow of tiny events actually keeps the HTTP connection alive. So it's literally the difference between your generated response successfully arriving or having your system just drop a fatal 504 gateway timeout error right on your screen.
All right, let's move right into our core focus for today, the one example, real-time display and billing. Okay, so let's walk through the 3 exact implementation steps you need in your code because these have to happen in a very specific order. Step 1, you set up a loop for text in stream.textstream. This is the part that captures and prints each little chunk immediately as it arrives over that persistent connection. Step 2, and you absolutely cannot forget this, you must use the argument flush equals true. This is basically the magic instruction that forces your system's buffer to clear out instantly. Without it, your system might just lazily batch the text together behind the scenes, which completely defeats the entire purpose of streaming. And finally, step 3. After the loop is completely 100% finished, you call getFinalMessage. This returns the completed message object, which, as we'll see, is exactly where you need to pull your token counts from.
So when should you actually be using this in the wild? The rule of thumb is actually pretty simple. Use streaming whenever a human is actively watching the screen. Think chat interfaces, live document drafting, coding assistants. They all rely on the user being able to read and react before the generation officially finishes. And of course, you'll also want to use it just to avoid those 504 timeouts on massive tasks, even if you aren't displaying it in real time. But, when do you skip it? Well, if you're just doing background batch processing pipelines where no human is watching and the responses are short, just keep your code simple. Stick to a standard synchronous API call for that.
Now, if you take only one thing away from this entire explainer, please let it be this golden rule right here. Read your token usage only after the stream is fully complete, never ever during. If you try to extract your token counts midstream, you are going to pull partial numbers. And those partial numbers, they will completely corrupt your billing logic and absolutely destroy your rate limit decisions. Just wait until the context manager fully exits, and I promise you the rest of your integration will function flawlessly.
So it really all comes down to this. Streaming is literally a one-argument change that fundamentally rescues your application's user experience. So I'll leave you with this question to think about. Will your next integration force your users to sit there and stare at a blank screen, or are you going to implement that one line of code to stream instantly? To get the full chapter on this, complete with 3 worked examples and a deep dive into the common pitfalls you need to avoid, head on over to the Claude Master ebook at claudemaster.net.